All right, guys. So we're going to go ahead and check the warm-up. So your quiz next class, you are allowed to use a calculator, but eventually you need to be able to do these graphs without the calculator. So I would recommend doing them as much as you can without, just so you get comfortable with it. We can go in any order. Could I have someone just help me with one of these? So what were some things that you were thinking about? Okay, yeah, Woody.
So I know that based on the equation, I know that the vertex is at -1, -1.
Good. So that's your h value and your k value. The h you need to think opposites for, so that would be a -1, and then k would be the same, so it would be -1. So that new starting point for this graph is going to be there instead. Well done. Okay. Would you can either continue or I can hear from someone else. So anybody else want to tell me what they did after this? Okay, yeah.
Well, since it's 4, like on the opposite premises, it's going to be stretched by 4.
Good.
So you would start by going from the vertex, you go 1 over to the right and then up 4.
Good. Because normally the cube root of 1 is 1, so I'd only be going 1 space up, but I'm multiplying that distance by 4. So I'm going to go 1, 2, 3, 4 spaces up instead. Good. The next perfect cube is 8 spaces over, so 1, 2, 3, 4, 5, 6, 7, 8. And what is the cube root of 8? Good. And so instead of going 2 spaces up, I need to stretch that by 4. So Katie, how many spaces am I going to go up? Exactly. 2 times 4 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Awesome. Okay, so that's this half of the graph. Is that it for a cube root, or is there more?
There's more.
Okay, so the square root only has this branch. The cube root goes in both directions. So I would just recreate it on the other side as well. So normally if I go 1 space to the left, I go 1 down. I'm going to go 4 spaces down instead. 1, 2, 3, 4. And if I go 8 spaces to the left, I'm going to go 8 spaces down. All right, and if it helps while you're still getting used to this, you can always put in the parent graph. So I'll show you kind of what I did there with that. So I put the parent graph kind of dotted in here first, and then that way I could check each of the distances and say, oh, that's a distance of 1, so I need to go up 4 instead. This is a distance of 2, and so I need to go up 8 instead. So that's always an option as well. Questions about that? All right. So could I have someone tell me about another one of these? Doesn't matter which one. Okay, yeah, thanks, Max. Okay. And then is there another one where it's saying the square root of 144 in here? Good. So one thing we talked about last class is you're going to have to get used to in this unit that square roots can also be written as a fraction exponent of 1/2. And same thing, cube roots can be written as a fraction exponent of 1/3. So they mean the same thing, you just have to get used to it. So if we check some of the others, what is the cube root of 8? Okay, which means this is the same thing. It's saying the cube root of 8, which would be a 2. All right, what is this asking? Good, so it's saying square root of 25, which is 5. What's the cube root of 216? All right, good. The cube root of 1,000? Yep. And then the square root of 196? Okay. Questions about any of those? Okay. And then one of the last things that we did last class is the compositions, which is basically just substitution. You just have to get kind of used to it. And so I color-coded it for my purposes because it helps me visualize it. You don't have to do it that way. But take a moment just to double-check how you did and let me know what questions you have. A couple of common mistakes. When you're subtracting, don't forget this means you're subtracting all of g of x. I have to subtract both of these terms. So notice their signs are going to change. It's now a negative 22x to the third and a positive 14. So that's one common mistake. Another common mistake is this means 2 divided into this whole thing. So it has to go into both terms. Sometimes people divide into the first one and forget to divide into the second one. So just be careful with that. And then notice you're multiplying 3 things here. When you're working quickly, it's easy to do the first 2 and forget to multiply the last one. And you don't have to use the box to multiply, but you can. So once you've multiplied those 2 things together, you still need to multiply that 2 to everything. So questions for me about any of that? Okay. So your quiz next class will include this and then also what we're doing today. So we're going to do our notes on the yellow pages. We're going to make it sort of like a foldable. So if you fold it in half, long ways. And the idea is that you could cut along these lines and then you'd be able to open it up and see examples of each of those different rules in there. All right, so when you guys were in Algebra 1, you learned about these exponent rules, and so we're going to review them together and then also expand upon them a little bit. So, one thing that you didn't learn in Algebra 1, but we will be doing, is rational is just another way of saying ratio. And a ratio, one way of writing a ratio is writing it as a fraction. So a rational exponent would be something like what you just saw on the warm-up. It would be something like this, an exponent that is a ratio, or a fraction. So we're just going to get used to being able to write things like that. And so when I write a rational exponent, I can rewrite a radical where the power goes on top and then the root goes on the bottom. So this a value had a power of m, and then it had a root of n. All right, so we're going to open up and do a couple of examples, and then we'll talk about the next one and do examples for those. So the two examples for rational exponents are here. So you're going to go backwards and forwards. You're going to take this rational exponent and write it with a radical, and then you're going to take this radical and write it as a rational exponent. Yeah. So it's power on top and root on the bottom. So if it helps, you can always label it while you're still getting used to it. So if I wanted to rewrite this one, what sort of radical do I need to create? So is it a square root, a cube root, a fourth root, fifth root? Good. So the root's on the bottom, so that's going to be a cube root. And then what sort of power am I going to give to this base of negative 64? Yeah. So I can either write a 1 as an exponent. Normally we don't see exponents of 1, but that would be correct if you want to put it there, just as a reminder. All right, so if I take this base of m, what would its new rational exponent be that shows the power and the root that we see here? Okay, good. So in this case, the power is 3. So that's going to go on top. And the root this time is a square root. So I'd show that with a 2 on the bottom. All right, and so once again, it's always power on top, root on the bottom. And that's new. It'll get easier. We're going to do more practice, so don't worry if you don't have it just yet. But at least you'll have some examples to help you. Questions for me about that? Okay. So the rest are ones that you would have seen in Algebra 1, but it's been a while. So does anybody remember, if I'm multiplying two things together and they have the same base, I can rewrite them as just 1a. But what do I do with their exponents to say how many are being multiplied? Yeah. So you actually add them together. So it'd be m plus n. Yeah. So some examples of that, if we go and open up again. All right. So these have the same base, so I'm going to be able to rewrite it as just one of those bases. And then I'm going to be able to add those exponents together. The only thing that's a little bit tricky here is I'm adding fractions, and that's also something we probably haven't done in a while. So does anybody remember what needs to happen so that I can add these fractions together? Yeah. Good. They need to be, basically the denominator tells you the sized piece that you're looking at. So if I think about 1/2 and 1/8, a half looks like this, but an eighth looks like this. So I can't add them together right now unless I split them into the same pieces. So how do I change this so that it's into eighths? So what would 1/2 look like as eighths? Yeah. So if I divide this into eighths now, there's 1, 2, 3, 4 of them. Yeah. All right. So it would be the same thing as 1/8, and I'm adding 4/8 to it. And so the idea is if you think about it visually like this, now you can just count up how many 8ths there are. So I have 1, 2, 3, 4, and I have one more, which makes 5. So all together, I would have 5/8. Questions from me about that? All right, you're going to try the next one. So you're going to rewrite these so that they just have one base of m. And you can have someone tell me what they put as the exponent for that one. Yeah, Byron.
M to the 7.
Good. A common mistake here is putting m to the 6th, so don't forget that this m right here, maybe you draw in a 1 just to remind yourself that there's one more there that you're adding in. All right. Good. All right. So notice this time I have one base that has 2 exponents, and those exponents are separated by parentheses. So what do I do with those exponents this time? Yeah. In the same way that if you have things that are separated by parentheses, you multiply them together, think of doing the same thing here with those exponents. All right. So I'm going to have c with some sort of new exponent, and the exponents here are fractions. Does anybody remember how do I multiply fractions together? We talked about how to add them. Yeah, so you actually just go straight across. So 1 times 2 is going to be 2. 4 times 3 is going to be 12. And then that's my new exponent. Does it simplify anymore, though? Yeah. So c to the 1/6th power. Good. So if I look at the next one, what would be the new exponent for x? Good, so it'd be 12. And then, are these alike? Can I add their exponents together, or would it stay like this? Good. Wonderful. Yep. Questions about that? All right. So the next one we're going to talk about is very similar to this one, power of a power. It's just that if I have more than one thing, I need to make sure that both of them get that exponent. It's kind of like distributing. So A would now have an exponent of m, and B would also have an exponent of m. All right. So I need to think about giving both of these things this exponent of 1/2. So 25 now has an exponent of 1/2. And then what would be the new exponent for x, since it already has an exponent of 3? Okay. So it would be 3/2 in that case. And knowing what you know now about exponents of 1/2, which means a square root, will this simplify more?
Yeah.
What will it become?
5.
Yeah. So that just means the square root of 25, which is 5, and then we have x to the 3/2 power. All right. So what's going to be the new exponent for a here?
24.
Good. So it's going to be 24, because I'm multiplying those together. And then what's going to be the new exponent for b?
2.
Good. So you're going to get 10/5, because 5 times 2 is 10, and then we have over 5. And then, like Will said, it's going to simplify to be 2. If these had the same base, I would add their exponents together afterwards, but they don't. Questions about that? Okay. So whenever we're working with exponents like this, if you ever have a negative exponent, you're not going to leave it as a negative exponent. A negative exponent just makes something move. So for example, this is a whole number right now. So that negative exponent is going to turn this into a fraction, where instead of being in the space of a whole number, it's going to move down underneath the fraction bar. That'll become a positive exponent now, and it'll be underneath 1. All right, so a couple of examples of that. All right, So here's the thing that has a negative exponent. Where is it going to move in this case? So it's going to move up with the 7 that's already there. The 7's not going to move because it doesn't have a negative exponent. So that's going to move up with it, and we'll have a to the 6th power. If I think of there being a fraction bar here, is there going to be anything underneath that fraction bar? Right. And so in that case, my final answer is this. Alright, so if I start to look at the next one, 6 does not have a negative exponent, so it's going to stay where it is. But where is g going to move? Yeah, it's just going to move down, and it'll have a positive exponent now. What about k? So it's also going to move down, and it'll have a positive exponent now. And that would be my final answer. Questions about that? Okay. All right. So this property and this property are essentially opposites. So when we're multiplying together, we add the exponents. So if we're dividing, what do you think we'd do? Yeah. Just be careful, you always do the top minus the bottom. So if it helps, maybe put a little note for yourself. Top minus bottom. All right, so if we see a couple of examples. All right, looking at these, they both have the same base. So I'm going to be able to rewrite them with a base of 27. And then I'm just going to be subtracting their exponents, the top minus the bottom. So I have 4/3 minus 2/3. So in the end, I'd have 27. And what would be the new exponent for that? Okay. Just so we can circle back a little bit and kind of reinforce things that you guys have been learning, if we think back to the first one, how could I rewrite this using a radical? Yeah. Good, exactly. This would be my power. This would be my root. So another way of saying that would be the cube root of 27 to the 2nd power. What is the cube root of 27? Almost. So it's 3. So it's 3. This actually simplifies a little bit more. So the cube root of 27 is a 3, and we have it to the power of 2.
6.
Almost.
Oh, wait, no, 9.
There you go. Yeah, because it means 3 times 3. So your final answer there would actually be 9. Good.
So we have to do that in the situation here, right?
Right, yeah. So by the time we get to the quiz, you'll be simplifying things. It'll tell you to simplify. There are no directions in this one. So like if this were the question on the test or quiz, you could just write it like this. But yeah, on the quiz, I think it'll say to simplify completely. Yeah. All right, questions about that? Okay, so if I look at the next one, I have r's that have the same base. I'm going to rewrite it as r, and I'm going to be subtracting the exponents. I'll have 1 minus 7. And then I have t's as well, so I'm going to rewrite them with one base, where I'm doing top minus bottom, so 15 minus 10. So if I start to simplify that, my new exponent for r is going to be negative 6, and my new exponent for t would be 5. Could I have someone tell me, why is this not the final answer? Yeah. Good. So thinking about the example we just did, there's a negative exponent, so then Colin, what would it look like, the final answer?
T to the 5 over r to the 6.
Good. So the t is going to stay where it is. It doesn't have a negative exponent, but this will move down to get a positive exponent. Awesome. Questions about that one? Okay. All right, and the very last one is similar to what we talked about here. If there's more than one thing that's getting this exponent, you have to make sure they all get them. So even if what I have is being divided, each of these things is going to get that exponent. So I'll have a to the m power over b to the m power. right, so I can see that both of these things need this exponent of 1/3. So x to the 1/3 power over negative 125 to the 1/3 power. And if I simplify that a little bit more, notice this doesn't have a negative exponent, so it's not going to be moving. But what is, this means a cube root. What is the cube root of negative 125? Good, it would be negative 5. And same thing again, a common mistake is looking at this and saying, oh, that's a negative number, I need to move it. But it doesn't have a negative exponent, so it's actually going to stay where it is. So just be careful with that. It's only negative exponents that move, not negative numbers. Another option here is if you don't like these rational exponents, you could rewrite this as the cube root of x over negative 5, and that would be fine as well. It means the same thing. All right. So taking a look at B, I'm going to deliberately make a mistake, and I want you to tell me what the mistake is. Okay, yeah?
You didn't distribute the second power to the 6th.
Good. So just be careful with that. It's easy when you're working quickly to look at this and think it's all one thing, but I need to make sure that everything gets that exponent. So it'd be 6 to the 2nd power as well. So if I simplify that a little bit more, what is 6 to the 2nd power?
36.
Good, well done. So that'd be 36t to the 12th power, u to the 2nd power. I don't have any negative exponents, so everything's going to stay where it is, and that would be my final answer. So the one thing that's nice about exponent rules is as you get used to them, it's kind of just like little puzzles. Everything, even the most complicated things, end up just being little puzzles. So we are going to jump back into the notes and just do some practice problems with these. All right. So if we loop back to what we talked about at the beginning, which is probably one of the newer things, you wouldn't have seen this in Algebra 1. So once again, whenever I have a rational exponent, the power is on top and the root is always on the bottom. And so you're just going to want to get comfortable rewriting it to show that. All right. And one thing to notice is when I rewrite this in radical form, my power is 2. So I can either write that as an x squared inside a cube root, or I can write it as the cube root of x and square that amount afterwards. So when you start simplifying, you can use either one of these depending on what you think will be easier. Because we are going to simplify some of these things. All right. So how can I rewrite this as a rational exponent? So we'll start with the 9. What would be the rational exponent for the 9? Yep.
It would be 5 over 2.
Does 9 have an exponent of 5? The m does. What would technically be the exponent for the 9? How many 9s are there?
1.
Yeah. So it technically has an exponent of 1. So it would have a power of 1, and then it's a square root, so it would be a root of 2. All right, but then Byron, the exponent you said would work for the m.
Yeah, so it would be 5 over 2.
There you go. Good. All right, so we've rewritten them as rational exponents, and then we just double check and see, does anything simplify more? This means a square root, so what is the square root of 9?
3.
Yeah, so that's going to be 3m to the 5 over 2 power. All right, you guys are going to try the next 3, and I'll walk around. So if you have questions, let me know. All right, so from walking around, I saw lots of correct answers, and I got some similar questions. So I saw a lot of people that were able to do y to the 18 over 3, so power over root. How come that's not the final answer? What would the final answer be? Yeah, so you can simplify this, and it'll become an exponent of 6. Questions about that one? All right, so take a moment just to double check the last two. So you could either rewrite it right away, and 2 divided by 2 gives you an exponent of 1, or you could square that 4, which gives you 16, and the square root of 16 is 4. So either way, we'll give you the same answer. Questions about that? Yeah?
Why is it 4 over 3?
Because we're doing power over root. Yeah. Other questions for me? All right. Oh, yeah, so the power, you can see it here. The power might either be inside the radical sign or on the outside. Still is the same thing. Yeah. Okay. So, in that case, now we're just going to go backwards. We have the power on top and the root on the bottom, and we're going to rewrite them as radicals. So I can see that I should have a power of 3 and a root of 5. So I could either write it like this, where the power is on the outside, or I can write it with the power on the inside. Either one would result in the same answer. So these are interchangeable with each other. Either one would be correct. Okay. So you guys are going to try the next 3. My hint for you is this last one with an 8 will simplify a little bit more after you rewrite it. All right, could I have someone tell me about B? Yep, thank you, Katie. The only person I should hear is Katie. Gentleman in the back, thank you. Okay, go ahead. Good. So that would be correct, or you could write it as the cube root of r, and then the whole thing squared. Either one of those would be right. Well done. Good. For the next one, you could have simplified it from here, or you could have written it as a radical and then simplified. The final answer you would get for this is y squared, because 4 divided by 2 gives me 2. If I rewrite this as the square root of y to the 4th, when I think about this, y to the 4th would be 4y's. And when you're simplifying radicals, for a square root, how many groups do you need, or what needs to be in a group in order to be able to take the square root of it? So for a square root, any group of 2 I can take the square root of. So that tells me that one of these will come out and a second one will come out, and I'd still get y squared either way. Questions about that one? All right. For the last one, you could have written this as the cube root of 8 squared, or you could write this as the cube root of 8 squared. But you're going to get the same answer either way, because if I work on this one, what is 8 squared? 64. And what is the cube root of 64? Okay. Or, what is the cube root of 8? Okay. And then when I square that afterwards, what does it give me? So either way, I get the same answer. So that's why these are interchangeable. So as you get more comfortable with these, you'll be able to decide which way will be most useful to write it. Questions about that? Okay. So if we go ahead and flip over, the one last exponent rule that we need to talk about, which is the easiest one, is whenever you have an exponent of 0, that always is equal to 1. So looking at this, these have the same base and they're being divided. So what can I do with their exponents? So I can subtract them. So I'd be doing 2 minus 2. So that would be 4 to the 0 power. And anything to the 0 power is actually just 1. So I'll show you. So if I do 4 to the 0 power, it gives me an answer of 1. So this final thing will be 1 here. Not necessarily. So this next one, I'd be subtracting those exponents. So I'd get x to the 0 power. So what does that equal? Okay. The whole thing here is not being raised to the 0 power. What's the only thing that's being raised to the 0 power? Okay. So we'd have 4a times 1, because that becomes a 1. And when I multiply those together, that just gives me 4a. All right, what about this last one here? Yeah, because this whole thing is being raised to the 0 power, so that would just be 1. Wonderful. All right, so you're going to want to use your foldable. You have some practice problems here, and you have more than one rule at once. So kind of just be careful with that. We can go over a couple together. So why don't you guys give me a couple that you think look difficult, and we'll try them as a class, and then the rest you'll kind of try on your own. All right, Colin, what's one we should do together? Okay, so we'll try F together. So don't let these intimidate you. Once again, just treat them like puzzles and do little pieces at a time. So don't try to do everything at once. So I'm going to go ahead and start with just the top of this fraction here, and I'm going to ignore everything else. So if I'm looking at that, what do I need to do here? Yeah, I need to give everything that exponent of 1/3. So the 27 and the g both need to get that. So I'm going to go ahead and give the 27 an exponent of 1/3. And then 1/3 times 12. What will be the new exponent for g? Yeah, so 12 times 1/3 would be 4. So 12 times 1 is 12, and then divided by 3 is where that 4 is coming from. So the idea is if you treat it like a puzzle and do little pieces at a time, it'll slowly get simpler and simpler. And you'll be able to get down to the final answer. All right, so I'm going to keep ignoring these things and just keep focusing on the top part there. So I know that an exponent of 1/3 means a cube root. Is 27 a perfect cube? Can I take the cube root of that? All right, what is that going to be? Okay, so that's going to be a 3. And I'm also going to start paying attention now to this because these have the same base. And there's one of those g's there. So what can I do with those exponents in this case? Yeah, they're being divided so I can subtract them. So 4 minus 1 will be 3. So g will have a new exponent of 3. All right, so I've dealt with all of this now. I still have the times g to the 4th to the negative 7th power. All right, so now I'm going to start focusing on this. So what would I do with these two exponents? Am I adding them? Am I multiplying them? Good, so I'm multiplying them. So I have 3g to the 3rd. And then when I multiply those exponents, my new exponent for that g is going to be negative 28. All right, so as you can see, it started out looking pretty scary, but as we go one step at a time, it gets easier and easier, and it gets less intimidating. So the next thing I'd want to look at is, okay, these have the same base, and they're being multiplied. So what should I do with these exponents? Yeah, I'm going to add them together. So I'd still have that coefficient of 3, but I'm going to have one base here, and 3 plus negative 28 is negative 25. Okay. Can someone tell me why is this not going to be my final answer? Perfect. Good. Does the 3 need to move as well? No. Okay. So that's a common mistake, is looking at this and saying, oh, that's all one thing, I'm going to move the whole thing. The 3 will stay where it is, but that negative exponent is going to make this move down, and now it'll have a positive exponent of 25. Questions about that one? All right, so we can do one more together. What's another one that looks kind of scary to you? E? Okay. All right, so once again, just treat these like puzzles, do little bits at a time. I can either start by working with everything that's in the parentheses and try to simplify that, or I could start by distributing this exponent to everything. It doesn't matter, I can do either one. So what would you guys prefer to do? Distribute? Okay. So I'm going to start by giving everything this exponent of 2. So I'm going to start with this x here. What will its new exponent be? It'll be negative. So 1/3 times 2? So that'll be negative 2/3 now. Good. All right, this y needs that exponent as well, so it'll be y squared now. All right, so on the bottom, what will be the new exponent for this x here? It's 2/3 times 2.
4/3.
So that'll be 4/3. All right, and then the new exponent for this y, we have negative 1/2 times 2.
2 over 2.
Yep, so negative 2 over 2, which will
Which
become,
would be negative 1.
there you go, good. All right. So now I'm just going to look and keep treating things, doing little pieces at a time. All right, I can see these have the same base, and they're being divided. So what should I do with their exponents? Okay, so I should be doing top minus bottom. So I'm going to have negative 2/3, and I'm going to take away 4/3 from that. And we'll do that in just a second. I can see that these y's also have the same base, and they're being divided. So I'm going to subtract their exponents. So I'd be doing 2. Just be careful, I'm doing minus, and then that's a negative 1. So what's going to happen with this here if I have minus a negative? Yeah, so it's actually going to become plus a positive. So what I originally had was 2 minus negative 1. And minus a negative.
It would equal plus.
Yeah. Good. All right, so let's simplify this a little bit more. If I have negative 2/3 and I take away 4 more thirds, what would I have in terms of thirds now?
It would be x to negative 3.
So negative 2 take away 4 would be?
It would be negative 6.
There you go.
But then you would simplify it into negative 2.
Good. All right. The y's are going to have an exponent of what now?
3.
Okay. And then is that my final answer? Okay, so Audrey, what would I do?
Move x to the bottom and change that for a positive.
Good. So the y has a positive exponent. It's going to stay where it is, but this will move down underneath, and it'll now have a positive exponent of 2. Good. So that would be our final answer there. Okay. So you guys are going to try the rest. Don't get intimidated. Just keep doing little bits at a time, and it'll be easy, I promise. Feel free to work with people and ask me questions, so we'll give you a little bit of time, and I'll walk around. Okay.
Whole thing
Yeah, it's 6 negative 2. Yeah, but then you have to flip it.
Oh yeah. You're right.
So I got 3. Yeah, but I don't. Do you distribute? I don't know what to do next.
Wait, hold on. Okay, so 6 negative 2, e negative 2, u, what's 8 times negative 2? 6 negative 16.
Oh wait, no, it's not. No, it's not. Now let's see. Just like scared.
I never thought of that.
I'm so gross.
Negative x plus negative b.
Okay, I'm a little bit confused on B. I know because it was negative 2, so you would flip that. But would you do like this? Like you would.
Oh, if there's an equal sign, so if I have a fraction, this is a fraction, that's when you do multiplication. When I'm multiplying fractions, kind of like what we did here. When I'm multiplying two fractions together, I just multiply them straight across. So what you really have is all these things multiplied together.
So you over that.
Or you already, the negative exponents, you already moved them, so they're all in the brackets right now. Yes. Well, you keep simplifying. So if I have all of this over all of this, then I
Can you flip them around? Can you flip them around? Can I write like the actual one? Can I write down the this here?
Yeah. These are with multiplication. Like 2 times 3 is going to be something. You can switch those around. Yeah, you can switch these around.
Okay.
Yeah.
Oh wait. Did I do?
So I.
Oh no, I didn't.
Okay, so let's figure out why. It's a lot of minutes, right?
I thought.
That's like
I don't really saw you.
Yeah, that was how you gave out the second one.
Yeah, no, you
So the 6 is fine. He already had a 6.
I got the 6.
6 times negative 2.
And usually with one line, it's just like
Oh, I see. Did you?
Yeah.
So, yeah, they're different variables.
Yeah. Nope.
And I'll be right back. Alright, a couple more minutes for these. Let me know if you have questions or need help.
What'd you get for B?
For B? I'm almost there. Almost done.
Yeah, me too. I'm just stuck.
Hold on. Okay, so let me see your thought process.
Stuck.
Oh, you can You're supposed to multiply these numbers and then you
That's what I did. Wait, that's my stuff. No. I did this. She said it was right.
T6, right? Oh, down there. Yeah.
Did you get 4?
Six squared is 9 divided by 1. Wait, no.
No, you're right.
No, it's 20. Okay, so wait. Your
Where are there
It's just like she goes around, but she's like a clock. Like in the question,
by the time they get to it, you're like actually off the garden.
it's just like, oh my god, please. Dude, when I had to get my permit, I read it like all day. So bad.
It took me like, I want to say 5 hours. Like,
Everyone does. It's so funny because they're everyone's like early in the morning,
and they always overcomplicate stuff.
and they always close everything and then they over like they bring everyone home, but then they're just like sorry we're closed. Everyone's got they actually like all the out. Like I mean, I would never work at night.
Yeah, really would. I feel like it'd be a horrible job.
Those people are patient.
Yeah.
This job is
Alright, hold on 1 second. Alright, so take a moment to double check D. We'll move up and look at the top row in just a second. Shh. You can either move your exponents at the beginning or you can move them at the end. I personally think it's more helpful to move them at the beginning and then simplify, so that's what I decided to do. If you didn't have to, you would get the same answer even if you didn't. So I looked at this and I said, well, that 7 is negative, but it doesn't have a negative exponent, so it's going to stay where it is. That 2 has a negative exponent, so it's going to move up with that 7. This x and this y on top are both going to have to move down. So questions just about what I did in my first step and how I got to this point. So from there I said, well, negative 7 times 2, that's negative 14. There's only one base of x here, so that'll still be x to the 4th. But I have y to the 8th times y to the 3rd, and I should be adding those exponents, so that'll be y to the 11th now. Yes?
Can you show me B?
You said B?
Yeah.
Yep, in just a second we're going to look at the top row.
Oh, okay.
Yeah. Any other questions for me about D?
Hey, I was right.
Well done.
Shoot, but you told me it was 0.25, not 4.
Yeah. Well, shut up. I got that part wrong.
Okay. Alright, so here's the top row. We'll go in order, so I will talk to you about B in just a second.
Jeez, your B looks more organized than I do.
Okay. And that's all. I'll give you some tips about how to decide the best way, like the easiest way to go through something. But let's look at A first. So I looked at this and said, alright, I need to multiply those exponents. That'll be 3 to the 10th. And then I looked at these and I said, well, those have the same base, so I can rewrite it as 3, and since they're being divided, I can subtract their exponents. 10 minus 8 gives me 2, and 3 squared is just 9. Questions about A? Okay. So for B, one option, and it's what a lot of people were doing, which is fine, is you can go ahead and give this negative exponent to everything that's in these parentheses. That is one option. Another way to look at this is, if you look at what's inside the parentheses, we have a lot of things that are the same. Like, I can do 6 divided by 3. I have t's that are being divided. I have u's that are being divided. So it might be more helpful to try and simplify all of this first, and then distribute that exponent afterwards. That way there's less to keep track of. Because you'll get the same answer either way. So that's what I decided to do, is I looked through and I said, well, 6 divided by 3, that's going to give me 2. When I multiply fractions, I multiply straight across. So that u squared is actually just going to be on top with this, and that t is going to be in the bottom here. And I looked and I said, well, I have t's, so I can subtract their exponents. And I have u's, so I can subtract their exponents. And when I did that, I finally got 2 with t to the 5th power, and then just 1 u. Yes?
So on the top says 3u times t,
Mm-hmm.
3t, u, that change it all.
So it doesn't change it because if I think about just regular numbers, 3 times 2 gives me 6. And if I change the order and I say 2 times 3, that also gives me 6.
If you're multiplying it in there.
So in terms of changing u times t or t times u, this is still the same thing. Yeah. Good question. All right, so any other questions about how I got this far? Alright, so once I simplified everything inside, I said, alright, now I'm going to go ahead and distribute that negative. That way there's only 3 things I need to give it to rather than all of these up here.
Oh, yeah, that's good.
Yeah, so that's one thing, as you get more comfortable with this, you can look at what's inside the parentheses, and if you're able to simplify what's in there, maybe do that first, because it gives you less to keep track of. Because if you were distributing this -2, you weren't wrong, it's just that you had a lot of things that you then had to start moving around, and it gets frustrating, and I realize that. So I gave the -2 to all of these things, and I realized that a negative exponent to this 2 would make it move down. So that would be 2 to the 2nd power, which would be 4 on the bottom. T would have a negative exponent of 10, so that's going to make it move down to the bottom. And U with a negative exponent of 2 is also going to move down, so it'll be U squared at the bottom. Questions about that? Alright. With the last one, people were doing things in different order, which is totally fine. I chose to distribute this exponent first. And so 4 to the 1/2 power is another way of saying the square root of 4, which will give me 2. And then b to the -4th power times half will be b to the -2nd power. Since all these things are being multiplied, I can go through and I just found all of the regular numbers. So 3 times 2 times this negative, which is a -1. All of that's going to give me this -6. And then I looked through and I found all my a's, and if they're being multiplied together, I'm adding their exponents. There's 7 of them all together. And then there's just one of those b's, but it has a negative exponent, so it's going to have to move down. So what are your questions for me about any of these practice problems? Anything that you're having trouble with? Okay. We have one last example that's really quick. So like I said, compositions, we're going to kind of sprinkle them throughout all of the lessons. That way, by the time we get to them at the end, they're super easy for you. They work the same way. They are just plugging in. So if we take a look here, I have f of x, which is 2x minus 1. And I have g of x, which is 3x squared minus 4. The only thing that's different today is here they're telling me to find f of 4. Does anybody know, what does it mean if it's telling me f of 4?
Would you multiply 2x minus 1, or?
So what it's actually doing is, notice that instead of an x, it has a 4. So what it's telling me is to take this f function and replace the x with 4. That's all.
Oh.
Alright, so notice that instead of f of x, I have f of 4. It's replacing the x with 4. So what that's telling me to do is take this f function and replace the x with 4. So I'm going to have 2 times my x value minus 1. I'm going to replace that x value with a 4. So that'll give me 8 minus 1, which will just be 7. Alright, so the next one says g of -3. So notice instead of g of x, I have g of -3. It's replaced the x with -3, so that's telling me to use the g function and replace x with -3. So I'd have 3, my x value is squared, and then I'll take away 4 from that, and I'm replacing that x with -3. If someone were to write this as their next step, why is that wrong? Okay, so just be careful. When we square a negative number, that means -3 times -3, which will become a positive 9. All right, so 3 times positive 9 is 27, and 27 minus 4 is 23. So you're just using order of operations. All right, so if we get into more complicated ones, so for example, it's here it's saying f of 4 plus g of -3. I would just be substituting in 4 as my x value here, and I'd be substituting in my -3 as my x value here. We happen to have already done that, so we're going to save a little bit of time. What was f of 4 in this earlier one?
7.
Yeah, we got 7 from that. And what was g of -3 when we did it earlier?
20.
And so we're going to be adding those things together. Okay. If these were different values, ones that we hadn't already found, though, you'd have to find them first before you add them together. Questions about that? Alright, so for my last one, I'm using my f function and I'm replacing the x with 2. and I'm multiplying that with g of x, or I'm not replacing an x value there. So I'm going to take my f function, I'm going to replace the x with 2, and then I'm multiplying that with my g function. Which is 3x squared minus 4. Alright, so if I simplify this, 2 times 2 gives me 4. If I take away 1, what is that going to be? Alright, so I'll have 3 times 3x squared minus 4. So what will that become?
9x squared minus 12.
Awesome. Okay, so really the only thing that's new today is just how to deal with the fact that it's giving you a value to plug into the function first. That's all. Alright, so that is it for the lesson. You guys have a little bit of time right now to work on homework and ask me questions, so I'll walk around and let me know if there's anything that you need help with. Well done, guys.